Hi gentlemen, these will be your notes for Unit 2, Day 1. If you would like to see the warm-up or review problem worked out, then go ahead and look at the finished notes directly above the video notes in your module. You guys should have gotten your tests back and you should have looked through them. If you guys had any questions, you were able to ask today. So if you weren't in class, you can come before or after school and ask me next time you're at prep. So today we're going to talk about relations and functions and their domain and range. We're going to be able to use function notation like f of x and g of x. We're going to talk about the difference quotient. A difference quotient is like the slope formula. So you're finding the difference between two numbers. So like the change in y over change in x in the slope formula. We're going to be able to perform operations on functions. So like adding functions, multiplying them, subtracting them, dividing. And then we're going to talk about the key features of functions when we graph them. So relations versus functions. So a relation is any relationship between x and y. So for instance, if we had x plus 3y equals 15, we can call that a relation. If we had x squared plus y squared equals 4, we can call that a relation. It's any relationship, so it's any equation where you have a relationship between x and y. A function is going to be more specific than that. A function is a relation that passes the vertical line test. So that's one way to think about it. It's going to pass the vertical line test, meaning that if you were to graph each of these, only one of them would pass the vertical line test. So if I graph x plus 3y equals 15, I'm just going to graph it using intercepts. So the y-intercept is 5, 2, 3, 4, 5, and the x-intercept's 15. So I'm just going to put a 15 over here. And so notice, if I were to draw any vertical line on that graph, it would only intersect my picture once. So this passes the vertical line test. So it is a function. My second one, if I were to graph x squared plus y squared equals 4, you guys should remember from our last unit, that makes a circle. So the center is 0, 0, and then we go up 2, right 2, left 2, down 2. And so I have my circle. But if I were to draw a vertical line, notice that this passes through the circle twice. So this does not pass the vertical line test, so this is not a function. What that means in terms of ordered pairs. So for something to be a function, every x has only one y partner. So if I gave you a set of points like 2, 3, 1, 4, 6, 5, notice each x only has one y partner. 2 only has 3 as a partner, 1 only has 4, 6 only has 5. So this is a function. Something that would not be a function with ordered pairs could be like 2, 4, 2, 5, and 1, 3. Notice for this one, 2 has 4 as a partner, but 2 also has 5 as a partner. So since 2 is going to 2 different y values, that's not a function, because if you were to plot those points, it wouldn't pass the vertical line test. Mapping diagrams are the ones where they give you the ordered pairs as a mapping. So if I had 2 and then 4 and 5, so 2 would go to 4 and 2 would go to 5. So notice that x value of 2 is going to 2 different y values, so it's not a function. So these are not functions. And then graphs, we've already talked about, they have to pass the vertical line test for it to be a function. Domain and range. So if we remember, domain is going to be all the x values that exist on the graph. And then the range is going to be all the y values that exist on the graph. The easiest way to talk about domain and range is if you already have a picture of the graph. If you don't, we can find both of those algebraically. Domain's easier to find algebraically. But for range, I'm going to let you guys use the graph to find the range. So for this picture right here, the domain is every x value that this takes on. So notice it starts at -3, but since that's an open circle, it can't equal -3. So x is going to be greater than -3, but then notice the x values stop at 1, and notice this is a closed circle. So that means that it can equal 1. So x is going to be between -3 and 1. That is inequality notation. You can also do this in interval notation if you remember. So my x values are in between -3 and +1. Since x can't equal -3, I do a parentheses, and since x can equal 1, you do the bracket. So the parentheses go with less than or greater than, and the brackets go with less than or equal to, greater than or equal to. So that's going to be the domain. The range is going to be all the y values that this graph takes on, so the highest to the lowest point on the graph. The lowest point that this graph takes on is -4, and the highest y value that this graph takes on is 0, and it actually equals 0 right there. So my range, my y values are going to be in between -4 and 0, and since it can equal both, they can have less than or equal to's, or with interval notation, it would be between -4 and 0, both with brackets. On the one below it, this is a parabola. My x values, notice these arrows are indicating that it's going to keep going over in both directions. Since it's going to keep going over and over, my x values are eventually going to equal every value. So my x values can go between -infinity and +infinity, or with interval notation, you would go between -infinity and +infinity. Infinity is not a real number. You can't actually ever equal infinity. It's an idea, not a number, so we use parentheses for both of those. Or you can do the fancy looking R for all real numbers. The range for this parabola, well, the lowest value that this parabola will take on is 0. And then notice, again, the tails keep going up forever and ever and ever. So the highest value that this parabola will take on is infinity. So my range goes from 0 to infinity, or you can say y is greater than or equal to 0 if you wanted to use inequality notation. Function notation. So that's when you use f of x. That's how we would say that out loud. That's f of x. This is telling you that it's a function. So when you see this notation, you can know that it's a function right off the bat, meaning it will pass the vertical line test. And it's telling you that it's a fancy way of writing y, if you remember. It's telling you that y is the dependent variable, and it depends on x. So x is going to be your independent variable. It's telling you who goes on the x-axis and who goes on the y-axis. In physics, you see this more often, like you can have v of t, and this is telling you that velocity depends on time. So time is your independent variable. So in physics, these come into play more often, the function notation. So if you are going to evaluate f at 0, it's just telling you to take 0 and plug it in for each value of x. So this would be 3 times 0 squared minus 2 times 0 plus 8. And if I evaluate that, I would just get 8. F at 2 tells you to take 2 and plug it in. So it would be 3 times 2 squared minus 2 times 2 plus 8. Order of operations says do the exponents first. So 2 squared is 4. 3 times 4 is 12. So it'll be 12 minus 4 plus 8, which would be 16. F at -1 would be 3 times -1 squared minus 2 times -1 plus 8. Again, do your exponents first. So this would be 1 times 3, which is 3, plus 2 plus 8, which would be 13. F at 2x, so we're going to take 2x and plug it in. So it would be 3 times 2x squared minus 2 times 2x plus 8. Order of operations says do this first. 2x times 2x is 4x squared. So this would be 4 times 4x squared minus 4x plus 8. So this would be 12x squared minus 4x plus 8. And then lastly, f at x plus 2, we're going to take x plus 2 and plug it in for each x. So this would be 3 times x plus 2 squared minus 2 times x plus 2 plus 8. When you're squaring something, remember that means you're multiplying it by itself. So this is 3 times x plus 2 times x plus 2. I'll distribute here. Minus 2x minus 4 plus 8. I'm going to multiply these two together first and then multiply by 3. So this would be 3 times x squared. 2 times x is 2x. 2 times 2x is 2x. So put together, that's 4x. And then plus 4. Then minus 2x and then plus 4. And now I'm going to distribute the 3. So 3x squared plus 12x plus 12 minus 2x plus 4. And then combining like terms, I should get 3x squared plus 10x plus 16 if I did all of that right. If you guys see a mistake anywhere in there, let me know. So that is function notation and evaluating with function notation. Implicit versus explicit form of a function. Implicit can be in any order you want to. So like standard form, x squared plus y squared equals 8. If you have a graphing calculator, your graphing calculator cannot graph an implicit form. It has to be an explicit form for your graphing calculator to graph. Desmos can graph an implicit form though. So for instance, if I wanted my graphing calculator to graph x squared plus y squared equals 8, I would have to solve that for y. So in order to solve that for y, I would subtract x squared from both sides, and I would get y squared equals negative x squared plus 8. And then I would take the square root of both sides, and I would have a plus or a minus. So y is going to equal plus or minus the square root of negative x squared plus 8. If you have a graphing calculator, if you wanted to graph this, you would have to type in y1 would be the positive square root value, and y2 would be the negative square root value. And that would be the explicit forms of the implicit x squared plus y squared equals 8. So explicit form just means you're going to solve for y. The y is isolated. It's by itself. So go ahead in both examples 1 and 2, try and put those in explicit form. So solve for y in both of those examples. And then you guys can check your work against the finished notes, which are right above the video notes. The difference quotient. We use the difference quotient often, especially when you guys take calculus next year, you're going to use it. The difference quotient is basically this. It's the slope formula. It's a change in y over the change in x, and that change in x is going to be h. So we're adding just a tiny value to change the x's by. So if we were to graph, and like we would just go right here, this would be my x value. All I'm going to do is I'm going to add a little h right here, and my new value where I'd be at would be x plus h. And so what I'm trying to do is I'm trying to find the slope basically between those 2 points. And so in order to do that, my original value, this would be f at x, and then this height would be f at x plus h. So remember, to evaluate the height, you would just plug in whatever x values you want. So if I want to do the difference quotient of this guy, it's going to be f at x plus h minus f at x all over h. So remember when we were doing the function notation up above, the first thing we're going to do is we're going to plug in x plus h into my function. So this would be 3 times x plus h squared plus the x becomes x plus h and then minus 2. So this right here is the f at x plus h. And then we're going to subtract f of x. Well, f of x is just the original function, 3x squared plus x minus 2. And then we're going to divide that whole thing by h. So this right here is f of x. So that is f at x plus h minus f of x all over h. So if I evaluate this, I'm going to multiply that out. So this would be 3, and I would have x plus h times x plus h, which I'm going to have to multiply out. That's going to be x squared plus 2xh plus h squared, and then plus x plus h minus 2, and then I'm going to distribute that negative into the next guy. So this is going to be minus 3x squared minus x plus 2. And this is going to all be over h. I'm going to distribute that 3 now. So this is going to be 3x squared plus 6xh plus 3h squared. And then I have plus x plus h minus 2 minus 3x squared minus x plus 2 all over h. Watch what happens. I'm going to add a page because I'm running out of room. Notice who cancels. So I have a positive 3x squared and a negative 3x squared. I have a positive x and a negative x, and I have a negative 2 and a positive 2. The original function ends up canceling, and I'm going to be left with 6xh plus 3h squared plus h all over h. Now, if you notice in the numerator, they all have an h term that I can factor out. So if I factor out that h term, then I would have 6x plus 3h plus 1 over h, and now those h's are going to cancel. So my final difference quotient is going to be 6x plus 3h plus 1. that idea is getting us ready to do something called the derivative, which we do often in calculus. So when you guys have a moment, go ahead and try number 2, and then you can check your work against the finished notes. So try the difference quotient for number 2. Finding the domain of functions. So we're going to do this algebraically, and then you guys can check your work on Desmos to see if we did these right. So if we were to look at x squared minus 4x, so you can just think about this one in terms of making a table. If I plug in 0, do I get a value? Yes. If I plugged in 100, would I get a value? Yes. If I plugged in negative 100 for x, would I get a value? Yes. Is there any number that you can think of where if you tried to plug it in for x, it would be undefined? No, any value that you can think of, if you plugged it in for x, you would get a y value in response. So that means that the domain of this guy is going to be all real numbers. If I were to graph this, it'd be a parabola, and parabolas don't have any breaks in their graph, so their domain is going to be all real numbers. If you are given a square root function, remember what's the one thing that can't happen in square roots? The inside can't be negative. Right? You can't take the square root of a negative number. If you try, you get an imaginary number. So whatever's on the inside can't be negative. So to show that, we would just, whatever's on the inside, which in this case would be 3 minus 5x, we say that that has to be greater than or equal to 0. You can take the square root of 0, so it can be 0, and then we would just solve this. So I'm going to add the 5x to the other side, and then I'm going to divide by 5. So x has to be less than or equal to 3/5 for this to work. That would be the domain of this function. If you put it in interval notation, x is smaller than negative 3/5, so the biggest it can be is 3/5, and the smallest it can be is negative infinity. So that's what it would look like in interval notation. If you have a fraction like number 3, remember the denominator can't equal 0 in fractions. So that's the one rule you have with fractions. So to figure out the domain, if it's rational or a fraction problem, is you say the denominator can't equal 0, and you solve it. So you can add the 9 over to the other side, or you could have factored, and then you take the square root, and then it's plus or minus. So x can't be positive or negative 3, but other than that, x can be any other number. So your domain for this one is plus or x cannot be plus or minus 3. For number 4, you've got a double dose because you have a radical, so you have a square root. So that means that x plus 2 has to be greater than or equal to 0. So if you solve this, x has to be greater than or equal to negative 2, but you also have a denominator. X plus 5 can't be 0. So x cannot equal negative 5. Well, x has to be greater than negative 2, so you're already good to go. So this is the only domain you need. So your domain is going to be x has to be greater than or equal to negative 2, or you would go from negative 2 to infinity if you used interval notation. You guys can go and graph all of these on Desmos if you want to check to see if we got the right domains. Operations on functions, they're going to work exactly how you want them to do. So if you're going to take f plus g of x, all you're going to do is you're going to take f of x plus g of x. So in this case, my f of x was 2x minus 5, and then we're going to add g of x, which is x squared minus x plus 2. All you're going to do is combine like terms. So this is going to be x squared plus x minus 3. F minus h of x is just going to be f of x minus h of x. So you're just going to subtract the 2. So this is going to be 2x minus 5 minus h of x was 3x over x plus 4. In order to subtract things, if one of them's a fraction, you need a common denominator. So I'm going to put this guy over 1, and then I have to multiply the top and the bottom by the common denominator, which would be x plus 4. So I'm going to have to distribute on that first numerator. So 2x minus 5 times x plus 4 would give me 2x squared plus 8x minus 5x minus 20. And then I'm going to subtract the 3x from the second numerator. And that's going to be all over x plus 4. Combining like terms, I get 2x squared plus 3x minus 3x. Those will go away. So 2x squared minus 20 over x plus 4. If I factored out the 2, I would get x squared minus 10, and I can't factor any further, so that would be as far as I could go. F times g of x, again, that's exactly what you think. It's f of x times g of x. So I'm going to multiply those two guys. So it'd be 2x minus 5 times x squared minus x plus 2. And then you would just FOIL this out or distribute it out. So we would get 2x to the third minus 2x squared plus 4x, and then minus 5x squared plus 5x minus 10. Combine the like terms, and you get 2x cubed minus 7x squared plus 9x minus 10. F over h of x would be f of x over h of x. And so I would get 2x minus 5 over, and then h of x is 3x over x plus 4. And then remember, that means 2x minus 5 divided by 3x over x plus 4. And when you divide fractions, you're actually multiplying by the reciprocal. And so if I did this, I would get, distribute here, I would get 2x squared. I think I've already done this, right? If I done 2x, x plus 4 times 2x minus 5. Nope. So then I would get plus 8x minus 5x, so that'd be positive 3x, and then minus 20 all over 3x. The top is a trinomial, the bottom is a monomial. They can't cancel with each other, so I leave it alone. And that is operations on functions. Graphs of functions. So remember, to be a function, it has to pass the vertical line test. We can talk about their characteristics just based on their graph. So if I want to know f at 0, I want to know if x equals 0, what's the height of the graph? So f at 0, here's x equals 0, so the height of my graph is going to be 4. So f at 0 is 4. F at 3 pi over 2, we're going to go to 3 pi over 2 on the graph, which is right here. The height of the graph there is 0. The f at 3 pi, we're going to go to 3 pi on the graph. So 3 pi is right here. And the height of the graph there is negative 4. All right, what's the domain of f? Remember, domain is all of the x values. So what x values can this graph take on? Well, it starts at 0 and it goes all the way over to, looks like 4 pi. So it's going to be between 0 and 4 pi. That's interval notation, or you can say 0 is less than x, which is less than 4 pi. Part C, what's the range? Remember, the range is your y value. So what heights does this graph take on? Well, it goes from a height, the lowest height is negative 4, the highest height is positive 4. So my range is between negative 4 and positive 4, or negative 4 is less than or equal to y, which is less than or equal to positive 4. D lists the intercepts. Well, the x-intercepts are where it crosses the x-axis, and it looks to cross the x-axis at pi over 2, 0, 3 pi over 2, 0, 5 pi over 2, 0, and 7 pi over 2, 0. The y-intercepts, where it crosses the y-axis at, is at 0, 4. How many times does the line y equals 2 intersect the graph? Well, here's y equals 2. It's just that horizontal line right there. How many times does it intersect? 1, 2, 3, 4 times. So for E, it intersects the graph 4 times. For F, it wants to know what values does f of x equal negative 4. So it wants to know when is the y value equal to negative 4. So where is the graph at a value of negative 4? Well, it's at a value of negative 4 here and here. So that is when x equals pi and when x equals 3 pi. And G wants to know for what values is f of x greater than 0. So it wants to know when is y greater than 0. That's the height of the graph. So it wants to know when is the height of the graph higher than 0. Well, it's higher than 0 right here. And that's between 0 and pi over 2. So between 0 and pi over 2, it's higher than 0. And it's also greater than 0. The height of the graph is greater than 0 here. And that is between 3 pi over 2 and 5 pi over 2 on the graph. And then it's also, the height is also greater than 0 right there. And that is between 7 pi over 2 and 4 pi on the graph. And so those are some characteristics of functions, or how we can read the characteristics of a function based on its graph. So collecting information about the graph of a function. You guys go ahead and you can graph this on Desmos. and then see if you can answer A through E based on your graph on Desmos. And then you guys can check your work against the finish notes. Let me know if you guys have any questions. And here's your homework for today.